everybody. Inside your project you see that I placed a demo with source code of WCF. Now in this video I will go through projects that we have and I'll give you a brief introduction to the source code, how it's working and what it's doing. So after that you can play with it more and you understand after that more and you can extend it. So opening Solution Explorer. We have several projects. We have WCF Service Calculator.web. After that we have its version like console application. We have a class library with that. After that I have calculator consumer, how we can consume our console application, and I have it for web as well. After that we have project with WCF Service Calculator.test. We have calculator async invoke and WCF REST service demo. So let's start with the first one, WCF Service Calculator.web. What we have inside it are two items. The first one is iService Calculator, which is the interface of my service, and Service Calculator.svc, which is keeping the implementation. So if I open iService Calculator, what we have here is, first we have our interface iService Calculator. I have the notation service contract, which is saying that this is the interface of my service. After that, inside it, I have a method integer calculate receiving first value, second value, and operation type with calculation operation. This method is having attribute operation contract, so this will make him visible for outside the world. Now, if I don't have it, then you cannot find this method. It's like it's not existing. But operation contract will make it public. As well, here I'm receiving as parameter calculation operation. This calculation operation is my data contract, which I define below. So I have public enum calculation operation, and I place here an attribute data contract. After that, for each enum value, like add, subset, multiply, and divide, I'm having the attribute enum member. After that, I have my SVC, the implementation of my interface. So what I'm doing here is I'm saying public class service calculator inherit iService calculator. Inside it, I implement the method calculate, and as well I receive the required parameters, first value, second value, and operation type. Now how that's working? Well, independent of operation type, using switch statement, I'm saying if operation is set, then I'm going to return first value plus second value. If it's subtract, then I'm going to subtract two values, after that multiply them and divide them. If I have different value, then by default I'll throw new argument exception saying that it's invalid operation. The third file that we're going to see is my web.config. What more specifically I can find in my web.config? Well, I have services, and inside it I defined my service. I give it the name WCF Service Calculator.web.service calculator, and with behavior configuration service calculator behavior, which is this one. Let's see the behavior. Well, it's inside tag behavior, service behaviors, and I defined a new one with placing the name. Here I'm saying that HTTP GET is enabled, this equal to true, and include exception details in false is false. Back to my service, after I specify its name and behavior configuration, I'm setting the endpoints. So the first endpoint has address localhost, my binding is WS HTTP binding, and the contract is the path to my file. So WCF Service Calculator.web.iService calculator. The other endpoint has address max with binding max HTTP binding and contract iMetadata exchange. And this actually how I'm configuring and I'm creating my WCF service. Alright, so if I close these files and close this project, let's go to the next one, which is the console. What I have here, if we review it, I'll see that I have the same file with the same code. Again, my interface iService calculator, keeping the same attributes, the method, my data contract for data members, and my enumeration variables. After that, I have service calculator with the same implementation. But inside this console application, what we can see more specifically is WCF calculation host. What is doing this code? Well, because this console application, my application will start from this main method inside WCF calculator host. What I'm doing here? Well, first I'm defining my service address, which is new URI from localhost on port 1234/calculate. Then I want to make a self-host on my service. How I'm doing that? Well, var self-host equals new service host. And here I'm providing type of my service, and after that on which address. Then I have to create new instance of service metadata behavior, and here I'm specifying the configuration HTTP get enabled equals true. If you remember, in previous example inside web application, I had web config and I specified this inside behaviors. Now, when we're doing this programmatically with C# code, not XML, I'm doing this with service metadata behavior. And here you have as well other properties which you might specify, like external metadata location, HTTP get binding, HTTP get URI, and many others. For now, what we need is only HTTP get enabled, which is equal to true. Then I'm getting my self-host and I'm saying .description.behaviors.add SMB, which is my service metadata behavior. After that, I'm saying using self-host. I'm doing that because I don't want to, let's say, forget to close it, because that could cause lately more exceptions, like, for example, Stack Overflow exception could be one of them. So I'm saying using self-host. After that, I'm opening it. And here inside my console, I'm saying the service is started at 10-point service address, and press enter to exit. And that's how you can build your console application to work with WCF services. The next example is where we have WCF service calculator.library. Again, I'm showing you that there is nothing different inside my iService calculator and its implementation. If we go to app-config, what we'll see? Well, I will have the behaviors again with HTTP get enabled true and include exception details in false. Here what I have the service with my name, and more specifically, I have host tag. Inside this host, I'm specifying base addresses, and here I'm adding new base address. So I'm saying that this will be on localhost port 8732 / WCF service calculator library / service calculator. Then I'm setting the endpoint, and I'm saying again basically the same that we had inside the web project. But here more specifically, what you need to take a look at is that I'm specifying my host and base address. Alright, inside next project we have calculator consumer.console. What we're going to do here? Actually here we would like to access service calculator client. What is service calculator client? If I go to definition, now this thing, let me show you from where it's coming. So it's coming from my calculator consumer.console.service calculator. What I would like to do here? Well, first, if I open service references, I can see that I have service calculator, because before that I added my service reference, so I have it referenced. Inside that service calculator is the source for accessing it, like Compass class. Let's see now how we can use it. Well, again, this is console application, so inside my calculator client, I'm saying var calculator client equals new instance of service calculator client. Then I'm saying that the result is equal to calculator client.calculate 3, 5, and calculator operation.add. Then, after I receive it, I'm printing on the console my result. So here, important thing to remember, you have right button, add service reference, you're writing down your address, and after that you're importing service calculator. When you add it, you can specify the name, and the name is this one, service calculator client, or you can change it. In my case, I use service calculator client. Then you're creating new instance of that, and you're just using it. So the next project is calculator-consumer.web. What I have actually here, this is web pages, and I have default.aspx, which inside it has aspx.cs file and my designer. Now we don't care for designer, that's why we're going to take a look at .cs file and .aspx. What I'm doing here? Well, I have some header. First, I'm trying to build my page. Assuming we have our doc type, we have HTML, we have some head, and after that we have our body. Inside my body, I'm creating form with ID form calculator consumer, which is run at server. Now, if you don't understand that, don't worry, this is more specifically to ASP.NET Web Pages technology, but I want to show that how it can interact with your UI as well. After that, inside it, I have my div with some first number, which is text box first number run at server. I have second number, text box second number, and I have button, which is button add. As well, I have button subtract, button multiply, and button divide. Here I have my label, which is label result. That's where I'm going to show the result. To run and test that, you have to run your project, which contains the service calculator WCF project, and then you can build it and test it live, how you're going to pass basically two numbers, and after that choose if you want to sum or subtract, multiply, or you just want to divide them. Let's see what's happening in the backend. Well, in the backend, depending on which button you click, button add, subtract, multiply, or divide, which are connected with these ASP buttons. So we have subtract, multiply, divide, and button add. Depending which of them you click, you will call different methods. Subtract will call button subtract underscore clicked, multiply with this one, and divide will go with this one. All of them are doing similar operation, but using different method of our WCF service. So if you go to add, first what we're saying is var client equals new service calculator client. And very important here is that again I added my service reference so I can work with it. Then I'm saying first number equals integer.pass this.textbox first number.text. This will get the value of your first text box, what you enter there. For example, 3, and in the second one, 5. So here again, I'm taking the value of second one and parse it to integer. To the end, I'm saying that this.label.text, so we're speaking for this label, is equal to the string result, two dots, and here I'm calling the method from the client. So I'm saying client.calculate with first number, second number, and operation is add. This will return, for example, the result 10, and what you get displayed inside label result will be result 2 dots 10, for example. We should now go through the other methods because they're all the same, just what we have different is that in this method button divide underscore clicked, I'm passing calculation operation dot divide. Here I have multiply, and here I have subtract, and here of course I have add. So it's not something special. Now inside next project we have some WCF service calculator tests. Now let's review how we can unit test our WCF services. So what we're doing here. Now first I have created a class calculator service unit tests, and then I added attribute which is saying test class. The package which I'm using is Microsoft.visualstudio.testing2.unit-testing. This is the default VSTS testing framework. So here I'm defining a private variable, private field actually, which is named underscore calculator client, and it's from type service calculator client. Again, service calculator client is referenced inside service references. Then inside my then I have a method test initializer, and I add attribute test initialize. What that means? Well, before executing each test, this code will be executed as well. So here I'm creating a new instance of my field, and actually I'm initializing it with new service calculator client. Now, Let's go through tests. So for each test, I have test method. That's how it will be found inside my test explorer when I run all tests. If I expand add test, what I have? Well, public void method add test with this attribute. Then I'm having constant integer a, which is equal to 5, and constant integer b, which is equal to 3. Then I'm defining constant with operation, which is calculation operation dot add. And I say that my expected result will be 8. So when I have 5 and 3 and add operator, I assume that I'll have 5 plus 3, which will be 8. What I'm doing here is I'm saying integer actual result, and I'm calling the method calculate from this.calculator client, and I'm passing a, b, and operation. Then I assert that are equal expected result 8 with actual result. Inside second test, this is subtract test. Here again I'm defining a, b, and my operation, which will be subtract, and then expected result 2. So I expect when I say 5 minus 3 to receive 2. Again, I'm calling the method, and I receive the value inside variable actual result, and then I assert if expected result and actual result are equal. If I expand, divide, and multiply test, here in multiply, I'm defining different calculation operation multiply, and I'm saying that I expect 5 multiplied by 3 to be equal to 15. I'm taking the result and I assert that. In the last test, I have 10, which divided by 2 should be equal to 5. Again, I have my calculation operation. I get the actual result and then I assert it. So this is one way how you can make a unit test of your WCF service. Now I have another project which is calculator async invoke. And here what I'm doing, I have referenced my service calculator with service reference. So I have class invoke calculator async. Then I'm defining and initializing private static field, which is service calculator client, and give it a name calculator client. Then inside my main method, I'm saying calculator client dot begin calculate, and then I'm passing my 3 and 5 as a and b of operation, calculation finished, and no. Calculation finished, this is actually here I'm passing a method. And let's see now from where this comes. If I go to definition, here I have begin calculate. So if I make control search and find on that, we can see that this is used inside my invoke calculator async, and after that I have it inside my reference. So what is this doing? Well, here let's see first what parameters I'm passing. I'm passing the first value 3, second value 5, my calculation operation, which is calculation operation.add, and then I have a callback and a sync state. For now we're going to keep our sync state no. And what is a sync callback? Well, this is when this operation is completed, is finished, I want to call some method and execute some code block. So I'm calling this, and when it completes, it will actually call this method. Inside this method, what I'm saying? Well, I'm saying integer result equals calculator client dot end calculate, and here I'm passing my async result. After that, I'm printing on the console what is my result. And that's how we can invoke calculator async. The last project from here is WCF REST service demo. So let's see what I have. Here I have category DTO. Well, that's model. DTO means domain transfer object. After that, I have the interface of my service, iService categories. I have here sample imported database, which is northwind.edmx file. Usually you might know or don't know that Northwind is the default database which you receive when you install SQL Server and Management Studio as well. So I have my model, interface, database, implementation, and web config. So let's begin with category DTO. Inside category DTO, what I have? Well, here I have public class category DTO with 3 properties: category ID, name, and description. After that, I have 2 methods. The first method is create from category, where I receive category, and this category is coming from my database model. This is from Northwind. Alright, and then I'm getting it. I'm creating a new instance of category DTO. I'm providing the values, and after that I return it. Then the other method is toCategory, where I'm going to return category, and here I'm going from my category DTO, I'm going to return category. And these are the 2 methods. So from category DTO to category, and from category to category DTO. Now I can make this as var, and we can also use object initializer in our case, like that. Alright, so that's what we have. We have our model, it has some properties, and we got 2 methods which are used to convert models, actually to map them. Of course, in a real-world example, in big applications, you're not doing methods like that. You got 3 options. If you're using linked expressions, you can set this inside your select statement, which is an option. Better option is if you use func from expression from category and category DTO. Then in that case, what you're saying, well, you're saying category DTO dot from category, and this will convert it. That's the second option, which is a little bit better, because if you're using link statement, well, everywhere where you need to map it, you're going to use the same code. But if you're using func from expression, then you're going to code it only on one place, which is category DTO, and after that we'll use it from here. So in the perfect case, you would use third-party packages, something like Automapper. Just FYI, Automapper is tool which is used for exactly these cases, but without writing any extra code. So if I have implemented Automapper, then I would say that, let's say, category DTO inherit IMAP from category. And then I'll be available to map this to that and that to that without any issues. But let's not go too far with details. So this is my category DTO with 2 methods. After that, I have my iService categories. What is doing iService categories? Well, first I make that notation with service contract. I have the interface, and then I have 3 methods. INumerable, which returns category DTO, and its name is getAllCategories. I have findCategoryById, which is receiving category ID and return category DTO, and createCategory, which is receiving category to create, which is category DTO, and return an integer. Now, what we know is that we have operation contract for each method, so it's visible outside the world. But because this is RESTful, then I have to add webInvoke notation as well. WebInvoke attribute has 2 parameters. The method, which could be get, post, put, get, delete as well. What is the method? Like here we have get, and post, and URI template. URI template is defining what is route and to which endpoint you have to go to hit this. Like getAllCategories, you have to go on category/all. FindCategoryById, you have to go to category/ and here provide your ID. For example, category/123, and to create new one, you need to make post request to category new. Let's see now the implementation. So if I open service categories.cs, what I can see? I can see that By the way, this is coming from my tools that I'm using. Let me just fix them so you can understand that that's not coming from code error. So, what I have implemented all these three methods, and let's see how they're working. Get all categories. I'm saying var context equal new instance of my Northwind entities. This is the DB context through which I'm accessing the database. Here I'm saying list from categories equal context.categories, order them by category ID and to list. Then for all of them, I'm saying categories.select category.dto.create from category from C. And I return it. Find by category, I receive the ID and parse it to integer. Then I create my context, I make the link query, select that so I can map it to category DTO and return it. Create from category, again, create a context, get that category DTO and map it to category, set the properties and return. Here add object to the context, save changes to database and return category DTO. Now what else we have to take a look at? This is my service categories.cvs. What I have here, well, my service host language C# debug equals true. I'm specifying my service, what is it called behind, and here I'm specifying the factory as well. Inside Northwind EDMX, so inside my database you can see that I have designer, I have Northwind entities, which is my DB context, which it's with its constructor, object set. Here I have object set for categories, and this is my category model. Still, this is another topic. Now, the last thing that I'm going to take a look now will be web config, what I specified exactly here to make this RESTful. So I have system.service model. Inside it, I have standard endpoints and web HTTP endpoints. Here, I created another element, which is standard endpoint. Here, I'm saying help enabled equals true, and default outgoing response format will be JSON. Of course, if you want, you can change it to XML. RSS is supported format as well. And here's the only extra thing that I have is connection string. What is connection string? Well, here that's not related to WCF, but it's related to database connection. Connection string, here you can have connection. It's specifying the data source and basically credentials to access your database. Here in our case we have Northwind entities, and here I'm specifying the data source is ./SQL Express, initial catalog, etc. etc. So, important thing, when you build this project, if it's not running for you or throwing some exception, please come inside web config and check your data source. So going to web config, connection strings tag, add connection string, the first one, and here to data source. Because when you open Management Studio, you see what is your default data source for localhost database. It might be not ./SQL Express. It could be, for example, only dot or the name of your PC. So the only thing that you have to do is open this thing, check your default localhost endpoint, your default server name, and just replace it with this one so it will run on your project. And of course, add the Northwind database with some sample data. Well, that was everything for the demo. Now you can play more with it. Here we have solution items, which are basically for test settings if you want to change them, and WCF demos vs MDI if you want to load some load tests, for example. So generally that was everything from the demo, and with that we're completing the course Introduction to WCF. Thank you very much for watching it, and good luck with coding. Cheers!